Hey guys, what is up? It's your pal Dave back again, live in the lab on a Sunday, which is a fun day for electronics. Sorry man, I can't do intros. Who we got? Some guys in the chat already. Strato McCaster, welcome. Alvaro, welcome. Crazy Boy, Cashier, welcome. Morning. So you must be in some crazy time zone, I'm guessing. So what are we doing today? So if you remember last time, we started building a version of the Auduino Synth using a 3D printed enclosure. Because a lot of guys kind of are into 3D printing now, and it's kind of a fun build. And we built up the basic circuit board using an Adafruit Permaproto 30-hole half-size board and an Arduino Nano, and that's where we got. And today we're going to finish this off, hopefully, and we're going to install all the off-board components. All right, so we've got a audio jack, we've got a DC input jack, we've got potentiometers, we've got a Midi jack that all has to be fitted into the board and connected to our circuit board with wires. So pretty simple. Hopefully it's all going to go well. Let me just do a little something here. All right, good. And what else? So yeah, so I was forced by Microsoft to install the stupid creators update on Windows 10, and everything's been really flaky. So if my thing cuts off, I'll just restart it, and I apologize in advance, but hopefully it's gonna hold on. You know, everything's been a little nuts. And oh yeah. I've also been working on this guy, which I've dubbed Cranky, the tweet printer. Is a thing you guys can do if you want to tweet to Cranky. Just follow Notes and Volts on Twitter, and then start your tweet with @Notes and Volt, all one word. It should pop up in the thing, and then just type whatever you want, and it should print out there. So, you know, there you go. So I don't know why, but it's kind of fun, and you know, go ahead if you want, give it a shot. Okay, so let's see. So this is a little diagram I built up to kind of visually illustrate how everything connects to the board. So this is kind of for you non-schematic guys. Sometimes it's a little easier to see it. So I have the schematic too, and I'll put a link once this is done. Where is it? Yeah, so there's the schematic, right? So if you can read schematics, this is really helpful. If not, you know, use the wiring chart, and yeah, pretty hopefully it's pretty straightforward. Now all right, so I think that's all we have to take care of, so let's get started. I got to keep one eye on the stream to make sure nothing goes horribly wrong. So let me get you here. Okay, so here's our case, and I kind of went over last time how to print it and what slicer settings in your software to use, but it's a pretty simple print. I printed it in ABS, right? So I only print ABS, so I'm not sure how this would work in PLA. I'm thinking it would work, but you know, I haven't tried it, and I can't try it, so if anyone tries it, let me know how it works, but ABS seemed to work fine. Now the next thing In the downloads will also be a front panel graphic that you can print out and laminate. All right. Oops, let's get rid of that. So you can print it out, and I just print it out on an inkjet printer. I use matte photo paper to give it a little, it makes it a little nicer, and it's a little stiffer than normal paper. And then I use, I don't know if you can see that, a standard office laminator, right? That, you know, one of those hot laminators. I got it from Staples. It cost me like $50 on sale or something, and I just really like it. I did the same technique for these guys, right? It's just printed, laminated to give it some durability. And what you do is you print it out. Make sure when you print it at full scale, right? And what I did is I put a little gradient at the bottom, in inch and millimeters. So just take a ruler after you printed and lay it across these guys and make sure that it matches the ruler. This should match an inch. This should match 20 millimeters. Okay? Then once you've printed it, carefully cut around the outside, right? You can use an X-Acto knife or scissors, you know, whatever you're comfortable with. You know, just try to do as neat a job as you can. And then laminate, put the cutout thing in the laminating sheet, run it through the laminator, and you'll get this. So you can laminate it before cutting it out, but I prefer to cut it out first because you'll see that there's a nice seal around the outside that also kind of acts like a cut line. So I found cutting it out first, then laminating it makes it a little better. Okay. So now we've got this, and we can cut it out and make our panel. Oops, wrong thing. There we go. Okay, so grab some scissors and just cut it out as neatly as you can. And I like to just leave that little seal line around the outside. You know, it's kind of like it's like arts and crafts back in school. So we'll just cut kind of the straights first, the straight lines. As someone pointed out the other day, you can also use a one of those paper cutters, you know, the guillotine type. All right, and the neater you do it, the better your finished product will look. But once again, I really enjoy this this way to kind of build up permanent versions of my projects. I find it looks great and it's pretty durable. Dom's 170, hi, how you doing? Welcome. All right, so we've got the main stuff cut out. Now we'll just kind of round these corners a little bit. It's kind of the trickiest part. And once we've done that, we should have a nice panel for our synth. What's that, Dom? You finished your class for this semester? Nice. So you got the whole summer to do whatever you want. I saw a funny kind of I don't know, like a post on Reddit, and it was someone said, man, I can't wait till the semester's over because I'll just be able to do exactly what I'm doing now, but I won't feel the guilt. All right, there we go. Nice. Looks professional. So now let's put it on our case. All right, that looks good. Let me just clean that up. No, it looks good. I like it. So you want to make sure that you see the labels here. They label the output jacks, where the jacks will go. So you want to make sure you put it on the right way. All right, cool. Now for the next step. Let's get a little room here. So what I do is I'm going to center this on the case as best I can. What you can do is you can hold it up to the light, and that will actually let you see the holes through the thing, and you can kind of line it up. That's pretty good. Okay, so get it as center as you can. And then we're going to take a nice sharp X-Acto knife. Watch your fingers and just poke it through the hole. Now the knife will, hold the thing solid, and the knife will kind of ride the edge of the hole. So just cut around the edge of the hole. I know I'm getting close to my finger, but the hole is protecting me. So I'm just kind of working the knife around the inside of the hole, and I should be able to cut out the middle. There we go. Okay, so once you've got the middle hole cut out, we're going to take a potentiometer. Okay. And I wrote a parts list on the link in the previous version of this, so you can see all the parts I'm using. Now, one thing about these potentiometers, and most potentiometers, if you see here, there's a little key, like a little tab, right? And what that does, or what it's supposed to do, is in some enclosures you would drill the main hole, and then a tiny hole next to it that this key would slot into, and that would prevent the potentiometer from rotating, right? But like in our situation, we're not building some industrial thing. It's fine. We don't need this. So we're going to cut it off. So take some half decent side cutters and just kind of cut that little tab off, and watch it go fly across the room. Yeah, a sec. There we go. So once it goes, it really goes. Okay, cool. So now that tab is gone, we can put it in our enclosure, and it will fit flush against the top of the enclosure. And if there's still a little left, you can kind of clean it up a bit. There we go. You just want to cut that tab down enough so it sits flush with the top of the enclosure. There we go. Perfect. Okay, so stick your potentiometer. Notice there's kind of a little cutout, which kind of follows the shape of the potentiometer, so the pins kind of go to the flat side of the cutout. And there it is at the top. Now we'll place our graphic over top. And then we have a washer and a nut that will tighten down. And this first potentiometer will hold everything in place, so you can really line up the rest. That looks pretty good, like that. Once again, I'm holding it up to the light just so I can see the other holes in relation to this. Now I'm going to take a wrench and I'm just going to tighten it down a bit. Don't have to torque it. Now at the bottom, check that it's straight. And then gradually tighten it. All right, pretty good. Just tighten that a tiny bit more. All right, great. There's one done. So now we'll just kind of do the same technique for the other guys. And you should find everything's kind of lined up a bit because we got our middle pot in there. And we'll just repeat what we did 5 times. Once again, take another pot, cut the tab off. Yikes! It shot across the room. I'll find that like in 6 years behind some filing cabinet or something. All right, so put the pot through, put the washer and nut on, straighten it up at the back, kind of hold it in place and tighten it. It's already looking like something. All right, there's 2. Let's do a third. This is the part on cooking shows where you wish you had someone come out and go, oh, here's one already finished. But no, we're doing it all live. All right. Take another pot. Tab goes bye-bye. And you may want to wear safety glasses while you do that because you don't want that flying up in your eyeball. I just closed my eyes. Drugadile, how you doing? Wayne C asks, do you prefer the aluminum case or the printed one? I like if I was going to build one for myself and use it seriously, I would probably go with the aluminum just because it's sturdier. It's kind of like a guitar effect kind of durability. But the 3D printed case, I wanted to try it because I know like sometimes these aluminum cases. This is a Hammond 1590 BB. They can be like a little pricey sometimes. If you're buying like in small quantities, they can be upwards of $20. I printed this case for probably like $1.90 in plastic. And you don't have to drill it, which is also another cool thing. All right, just tighten that up. that up a bit later. All right, 3 down, 2 to go. Once you got a few in, like the rest are easy because everything's firmly held in place. Wayne C says he will print in PLA. Awesome, man. Maybe let me know how it goes. So Dom says, about a year ago at a garage sale, I got a cheap toy Casio piano keyboard. I was thinking of trying to make a small portable MIDI keyboard for hackathons and other event. Yeah, sure. You could do that. Trick with like existing keyboards when you try to modify them is you have to matrix those switches up. They'll have in the keyboard something, it's called a switch matrix, that allows all those keys to enter the processor. So since there's so many keys, you can't really wire each one to a digital input. You got to matrix them. And also sometimes keyboards, like if it's a cheap one, it's probably not velocity sensitive. But if it is, that's like another set of switches, right? Because a lot of times velocity sensitive keyboards, the way it works is there's one switch that detects as soon as you press the key, another switch that detects when the key hits the bottom, and the time between those two events is the velocity of the key, right? The harder you hit it, the stronger the velocity is assumed to be, right? So it can be done, but you're gonna have to look at keyboard matrices, matrix size. All right. And last one. This is good. Everything lined up really well. I think 3D printing the way it is now is really, really cool. But it's not, like I wouldn't put out a finished, like a sellable product 3D printed yet, right? But I think once they kind of get it a little better so you can't see any, print lines between the thing, I think, yeah, that's going to be super cool at that point. I don't know if it'll be the current technology or something else, but once they make it so it looks like, plastic, molded plastic, then it's going to be super cool. All right, last one. In you go. Oh, did I cut the tab properly? Yeah, I already cut this one off. So that's Wayne C says SLA looks good. It does. It does for sure. Like, it's just got to come down in price, I guess. For us broke guys to get our own machines. All right, there we go. Pretty cool. Now I'm just going to go around and tighten these up just as best I can. And I'm kind of trying to point them in the right direction on the bottom. All right, I think that's good. All right, there you go. Now once, just for fun, let's test fit the knobs on it and we'll see how it's going to look. Kind of give ourselves a little encouragement. Look at that. That is tray sexy. What's that? Wayne says, try print and stain wood-filled PLA. That would be cool. That would be something for sure. All right, so now we can start adding the rest of our stuff. So we've got the Midi jack, right? It's going to go there. This is what they call a panel mount Midi jack. We have our audio jack that will go through the back here, and we've got a DC 2.1 millimeter barrel jack panel mount that will go through the top here, and we all have to do that in solder. So I'm going to switch to the other bench and I'll see you there. Okay, here we are at bench number 2. This is kind of my my construction bench where I do soldering and the like. What do I need? What do I need? I need these things. I need my board. Yeah, that's all I need for now. Okay, I just gotta make sure everything's centered. So now we can start wiring this up to our board here. Now let me grab this. And all right, so here's our plan. I printed one out. Here's our schematic, just in case we have to double check something. And you can kind of see how things are supposed to be wired. So basically, on each pot, if I'm looking at it like this, from the top, the pin on the right is all going to go to the ground rail. The pin on the left will all go to pin on the right will go to positive, plus 5 volts. Pin on the left will go to ground. Middle pin will go to one of our analog lines, A0 to A4. So what I did is I kind of showed all the grounds and powers, and then I just kind of said, hey, A0, go to here, right? A1, go to there. So it makes it a little cleaner to look at. Another thing is you don't need to wire each pot individually to a ground rail. We can chain all the grounds together and then run one to a ground rail, and then chain all the positives together and run it to the ground rail. So that's what we're going to do. And for this, I think I'm going to use stranded wire, 22 gauge stranded wire. So the difference between solid wire and stranded wire is stranded wire is a little more bendy, right? So if you're doing something like that needs to fold in and kind of get tucked into places, stranded wire is pretty good for that. But you have to make sure you get all the strands into the hole. So it's easy for one strand to kind of bend backwards, and then that could short something else. So a good thing to do is strip the end and then twist it, right? Make sure it's all one piece. Okay, so let's plan this out. What's the best way? So what I have is I'm going to A3, this bottom pot is going to go to my board, and everything else will just jump from where to where. All right, A3 to A0. I just want to make sure I don't. So that's going to be positive. Right hand, yeah. So kind of what we have to do, I'll try to make sure I'm in frame for you guys, is we have to put two wires, like if there's two wires to a to something, put both wires in, don't solder one and then try to solder the other. We're going to just do them both at once. Now the trick with this, since we got it installed, is getting that wire on these bottom ones here, getting it in there for the first time. So what I'm going to do is I'm going to bend the wire so I can feed it through. And I'm going to need my super cool looking visor to help me out. If you find it too hard, you can always temporarily take the pot out and do it that way. But I'm going to try to just get these bottom two. So like I said, I got one little strand that's not cooperating, so I'm going to cut it down. Trim up the edges. We're still going good. Yep, we're still going. Windows Creator Update has not knocked us off yet. There we go. Okay, so now I'm going to measure a length to get to the other side here. Doesn't have to be exact, but you want it as clean as you can get it. Now let's cut that. Now I'll strip it. Okay, so one side goes in, the other side goes there. Yep. All right, so I'll do my one side first. So I have to cut another piece that's going to go to our board, and we'll leave it kind of on the long side because it's better to be too long than too short. And we'll try to fit this. So I'm just going to cut a length, you know, a good length. Now I'll try to feed both of these through the thing, through the eye hole. It'll be easier said than done. Once we get these bottom two done, the rest will be easy. Actually, what I'm going to do is I'm going to take both these out. I'm going to twist them together. And if that gives me a hard time, I'm going to tack them with some solder, which I might do anyways. All right, let's tack these. Tired of their foolishness. So I'm just attaching together. I'm going to attach or just touch them with a little bit of solder, and that will make them into one solid thing that's not going to all right, there we go. Trick is, don't make a big solder blob that's too big to fit through the hole. Which I may have done. Oh man. All right, just get some of that solder off. That'll do it. Oh, go. It's going. There we go. Okay. I don't know if you guys can see that in there, but I've kind of just pushed them through the hole. All right, I bent it over a bit to make it fit. Now, we have to be very careful with the iron because this is plastic case. There we go. Easy as pie. Not really. All right, now we'll cut the excess off. Make sure that there's no shrapnel inside the case, right? Now we'll just kind of bring this other side over to here. Looks good. And so remember, we've got to jump another wire from there to the next pin, which will be the middle pin. So we got to get both wires in place first. right, so we'll get there, we'll cut a little bit. See if I can get both these in. Now, kind of what I'm thinking is for this point-to-point wiring I'm doing, I might switch to solid core just because these this stranded stuff's kind of annoying. So I'm going to do this one in solid. Yeah, I'm switching to solid. If I got any red solid. The reason being that these guys won't really move too much. So I don't have to, I don't have to worry about bending them. So to go from this to the board, I'm going to use stranded. To go pot to pot or whatever, I'm going to use solid. Much better. I'm kind of having to do them if you find you're having a hard time like getting this, you can take the pots out and do it, but I find it easier to do it while it's all in the case. All right, that looks good. Let's cut out the shrapnel, and now we're into solid wire for the rest. Just a little bit of shrapnel in there I gotta get out. Okay, so now we're just going to wire from that pin up to the middle. So I'll just cut a little extra, skip the end. All right, there we go. See, the solid core made it, and plus we're got more space in these middle ones, so it's a little better. And we're gonna put both wires in because we have to jump this somewhere else. Where am I going? To A2. Okay, so A2 and then across there. So go from there to there. So this is probably going to be the most tedious part of this build is this part, and the rest will be pretty quick. Okay, that looks good. Cut them out. And let's go from there over to here. Now let's strip it. Kind of forgot how much I hate wiring internal components. And we'll cut our second piece. It's gonna jump from there to there, and that will complete our positive part of this. All right, let's go. And one more piece over to here. And we only got one thing going to this pot, so I can just solder that direct. There we go. Positive. Done. You know, it looks a little funky, but I think it works. And I'll show you a good thing you can do. Before we move on, I want to test it. So we'll grab our multimeter, and we're going to set it to continuity. Now what continuity does, if you don't know, it basically turns your meter into something that beeps if the two probes are touching. So that means if there's a conductor between the two probes, it should also beep, right? So I'm going to put one on this end of the wire, and then I'm going to touch each joint. Good. All right, now I found a little issue. For some reason, this middle pot is telling me, hold on, there we go. That's probably why. All right, so You'll get a reading on the middle pin too if the pots are turned all the way to full open, because it basically means you're shorting one pin to the middle pin, if that makes sense. All right, good. All right, now we have to do the ground stuff. Do I have any green? I use green solid. Yeah, I'm going to go backwards on this. I'll start here. Once again, using 22 gauge solid wire. All right, good. And then we'll feed it across to this guy. So I'm basically just following the red wires, but on the opposite pin. How's the stream still going? Yep. So you thought building electronic instruments be all fun and games, right? It's a lot of just tedious work, but it's all worth it, hopefully. All right, now we got two wires coming off this, so we have to make sure they're both there before we solder them. All right, good. Once again, cut off the ends. Make sure the shrapnel's out. And I'll feed that to the middle pin. Now, as you're going, you know, kind of think about the best way to route them. You know, that's not going to interfere with anything, and you know, require the least bending and stuff like that. All right, there we go. And where's that going to go? going to go here. All right, so get my second piece. Also remember when you're soldering to make sure you heat up the wire tip and the pad that it's going to, because if you don't, if a part's not warm, it's not gonna, the solder won't stick to it. We'll move it over here. So what's the best way to get over here? I'm gonna go around this way. The reason is I got to get another wire in there, so I want to leave myself a little space. And we're getting to these like awful corner pots that are kind of a pain. Let's just get it through, and then I'll bend it. All right, there we go. Now I'll cut my second piece. Where are we? This will all be worth it in the end, I promise. I hope. A little shorter. So get around the corner. Take up electronics, they said. It'll be fun, they said. All right, there we go. Just gonna bend this. Perfect. We'll cut off our ends. Always making sure the little shrapnel pieces don't get stuck, because they'll cause you a lot of issues if they start rattling around in there. Okay, we're almost at the end of this part, thankfully. Am I still going? Yep. Okay, we'll get this in here. Okay, and now I'm going to take a piece of stranded. I don't think I have green stranded. It's 24. I don't have any green stranded, so I'll use orange. Nope. All right, so we'll use orange stranded for this, our ground exit from the board. Now if I can get this in, that'll be so great. I cut it down a little bit. And I'll touch a little bit of solder on that. It's a good trick to tin the top, put a little solder on your iron, and then just kind of run it along the wire. Let's get this out for a sec. Ah, didn't tin it all. Hold on a sec. It's going, yeah, there we go. Now let's get this solid piece. It'd been better if this wire was green, but I don't think I think I'm out of green stranded. Almost there. My pliers. Who's that? Diego, subscribed. Thank you. Thank you, man. Welcome aboard. All right. Diego is just like, man, watching someone wire up pots is something I could get into. But thank you. All right. Wow, that was a pain. I'll just get these two soldered and never speak of it again. All right, now I'll leave a nice long piece coming off for later. We'll just have to remember that orange is ground in this case. Okay, we'll do our check, our test, make sure. Strip the end of our wire here. We'll do our connectivity test. What does that Wayne see? How many voices does this have? It has one voice. Kind of two oscillators mixed into one voice. It's got a kind of a weird sound. Okay, there we go. So there's our ground and our positive wires hooked up. Now, you thought that was fun. We got to hook up our middle pins. And what do I got for that? I got red. So I got black. Let's do black wire for that one. Now this is a little simpler because we just have to hook up one thing per pin. So we'll just I just want to see how this works with the board. Yeah, it works fine. So we'll just take a wire, put it in, and solder it down. What's that Wayne says? Did you see the link to make a 4-voice wavetable synth? No, let me send it to me. I'd like to see it. So Wayne says, what will be the difference between wavetable and this one? And this is what we would class as a kind of a fake granular synth. So that means it takes little repeating grain patterns, like little pieces of, in this case, it'll be square waves, and just repeats them. So a wavetable synth is basically you're constructing like sine waves, triangle waves by reading a table of numbers. So instead of, you know, a transistor or an analog circuit making a sine wave, you're just kind of writing a sine wave numerically in a table, and then you read through the table and you get your sine wave. So it's a good way to create waves if your processor isn't fast enough to do it on the fly. That hopefully that makes sense. So this guy is not a wavetable, it's something else. I think, you know, the Shruti, I think that's how, from Mutable Instruments, I think that's wavetable. All right, getting close. I can feel it. Almost to the end of these pots. It's 2 down. How's the stream going? It's going good. That was kind of awkward. Oops. Three down. Yikes. Oops, cut the little end off. Sometimes you can use the cutters to pick up the little end piece that comes off. And the 2 corner ones I saved to last because they're the worst. Yeah, it's tight. Let me tin the end. And if I can get it in here, I'll be happy. There we go. One more. One more. All right, here we go. Last one. Oh, look at that. I'm just trying to push the wires out of the way so I don't burn them. Ah, there we go, pots. They are done. Once I cut the end off. All right, there you go. Looks beautiful. Okay, cool, good. All right, a little drink of water here. So that's the wavetable synth on Instructables. Turn your Arduino into a 4-voice wavetable synth. Cool, nice, I'll check that out. Okay, so now we can do some other things that aren't pots, thankfully. So let's do power. Okay, now here's one thing to think about. Here's our little power jack. This jack has to be installed from the front with a nut on the back, right? So one thing you got to remember is, don't wire it to your board until you've put it through the case and put the nut on the back, because you can't fit the wire over this. So that's a little thing to think about. Another thing we have to do is we have to figure out what pin is where, right? Which is power, which is ground. This is an important step. So let me come over here for a sec. There we go. Okay. Now here's an important point. You gotta pick your adapter, right? Now, the adapter I'm using, you want an adapter, I think you can double check the range of external power adapters for the Arduino Nano, but I believe it's around 6 volts to 12 volts is the range that it can handle. This guy is 9.6 volts. I'm using this because I've got a ton of them. These are Boss effects pedal adapters, and they're really common, and if you're a guitar player, you've probably got a ton of these. So what you need to do is figure out on your plug what is positive, right? Is it the sleeve here? Is it the tip, right? Because in your jack, notice there's a pin, and then there's a sleeve around the outside. You can't really see it. But you have to figure out if that pin is positive or negative when you plug this in. Now, it's easy to figure out because a lot of adapters, they'll have it written right on it. This one is saying the pin is negative, so the inside of the jack is negative, and the outside is therefore positive. So when I wire up my thing, I got to make sure that I connect the positive wire to the pin, or sorry, the shield, and the negative wire to the pin. All right, and I'll show you how you can test that. So first of all, let's do a little test and we'll figure out what the pin is hooked up to. Right, using our continuity probes once again. So I'm going to assume, like this one here, there's this odd looking one. I'm going to put the probe on that and then see if that's indeed the pin. And yes, it is. Okay, so that would mean these other two, I'm guessing, are the shield. And let me double check that. Now this is something you don't want to get wrong, because if you do, you can blow stuff up. Okay, so the big one is the pin, the other two are the shield. So in that case, the pin will be negative. Okay, so let's go back over here. And I'm going to make sure I color code this. So I'm going to take my stranded wire, and I'm going to use some little helping hands here to grip this thing. And what did I say? The pin is negative. So I'm going to hook a black wire up to that pin. So I'll know in my head that that's negative. All right, let's do that. How should I do it? And you also want to remember, like, which adapter. If your adapter's opposite, just reverse the wires, right? So you can use either pin positive or pin negative, but make sure you do it right. All right, leave a nice long piece. And then on the other pin, I will do a red wire to really strongly indicate to myself that that is positive. Let me just double check this. One thing I want to check is that both these. Now I'm going to plug in my adapter and do a measurement. You know, I don't want to. So turn my thing to volts DC, plug my adapter in, plug it into an outlet, and I take an actual measurement. So since I've decided this is the ground probe, like I put a black wire, I'm going to put my black probe to it. And then and you can see, you can't see because my hand's in the way. That I'm getting a positive voltage, right? And if I put it to the other pin, yeah, so this is the pin, 9.57 volts. If I reverse them, you notice I'll get a negative voltage, which means it's reversed. So I want to make sure whatever, when I put my black lead onto the negative terminal, I get a positive voltage, right? That means I'm doing it right. If I get a negative voltage, I got it backwards. Let's go back over here. And where are we? Red. We'll go and that hole's a little smaller, so I gotta make sure it's all Once again, make sure all the strands of your wire go through the terminal and they're not floating out, especially on your power. If you find you're having a little trouble, you can cut it a little shorter. There we go. Okay, that looks good. There's our jack done. Okay, so now we'll cut a nice long piece and we're going to install it in the case. So we'll install it through. That way we won't forget to put our nut on there. Now I got to feed the wires through the nut. We can see the case is printing well in PLA, so far about 50% done. Cool, man. Wayne's actually doing it live. Crazy, man. That's awesome. So maybe we'll have a live update on the PLA-ness. All right, there's our thing, and we'll kind of, where should we put the, put it so the little thing's pointed downwards. All right, let's tighten it up. Pretty it's tight in there. All right, cool. There we go. And while we're at it, let's just wire up everything into the case. So let's do the audio jack. Now this guy, you know, installs from the front, so we don't have to worry as much about the wires. But the one thing we do have to worry about is where's the tip, where's the sleeve, right? Remember, your audio cable, where's an audio cable, has a tip and a sleeve, right? When you put it in, notice the tip connects this thing here and the sleeve connects the other pin. So when we wire it, we got to make sure that our tip goes to the tab that connects to this, and I can actually see which tab it is. If you don't know, measure. Use your multimeter continuity mode trick. So why don't I make the tip red, and I'll make the other one black. I'm going to bend it over to give it a little, to help it hold in place. Remember, these tabs are big pieces of metal, so you might have to leave the iron on a bit longer to get it to stick. All right, that's good. And where's my black wire? I'll do the sleeve terminal black. Good. All right, there's our jack done. And let's put it in the case. Why not? Actually, I'm going to leave it out for a sec, and we're going to do the Midi jack. All right. Now, the Midi jack, hopefully you can see this. All right, there's two pins we need to use, and it's these two kind of, not the middle pin, but the two ones to either side. And if I look at it this way, it's basically pin 5 on the left, pin 4 on the right. But I'm going to actually be soldering it from the back. So I have to think of it this way, right? So when I do a red wire to pin 4, a black wire to pin 5, right? Hopefully the diagram makes it simple to see which is which. Now it's going to be, this is really tight in here, so it's going to be a little tricky, but nothing we can't handle. So what I'm going to do is use the other hand here to hold it in place. You know, always try to set up your soldering jobs so nothing's going to move if you can help it. I go inside out. And I'm going to grip the wire with this other plug. Can I see that? All right, everything looks all right. Be careful with this one because jacks are plastic. You don't want to overheat them. Looks good. All right, cool. Did I do that right? Ah, I did the red on the pin 5. No matter, I'll just have to remember. And we'll do, let's do orange on pin 4. Yeah, why not? All right, try to grip the wire. Cool. Cut the end off as always. All right, make sure nothing's shorting. And what I'm going to do with this, just to be extra sure if I can find it, I'm going to stick a little piece of heat shrink tubing over those terminals. Heat shrink tubing is really good. You know, if you want to ensure something doesn't short out, it won't, but you know, I'd just rather be safe. All right, there you go. Just slip it over. And then, what do we need? A little lighter. Where's my lighter? Should have a lighter somewhere. So what you need is a lighter to actually melt the tubing or shrink it, because it shrinks with heat. That's why they call it heat shrink. I got entirely too much junk. All right, just give me one sec, guys. I just gotta find. There we go. Where was I? Where am I? Where's my thing? There it is. Let's do another piece over the other side. You kind of put the tubing where you want it to go, and then we're going to melt it. Make sure you don't need much, just there you go. So you can get this other side. Perfect. You guys see that? So now those two wires are truly isolated. Okay, let's strip the ends. I'm going to run a little test. So with like finicky jacks, like Midi jacks and stuff, you know, always, you may want to test them, make sure that your joints are good. That's good. Nothing else is registering. I'll test the other pin. Good. Great. You know, it's better to test. Take 2 seconds to test than like sit there for half an hour trying to figure out why something's not working. So now we can put this in our case. And how am I going to do it? I'll do it with the pins pointing down like this, right? The pins at the bottom. Now what we're going to do with this guy is we're going to take 2 M3 8mm screws. And 2 M3 nuts, and stick the screws through. All right, screw, M3 nut on the back. And take a screwdriver, tighten that up. right, there we go. There we go. Everything's fiddly, you know? Everything's small and fiddly. Okay, cool. Just tighten them up so they don't move. There we go. Okay, 2 screws, 2 nuts on the back, M3 8mm screws. Audio jack, ready that to go. And that simply just feeds through the top. And I'm going to do it so that the tip terminal is kind of pointed downwards. Actually, move it to the side a bit just because I don't want anything, the wires kind of protruding under the bottom of the case a little bit. And tighten it up. All right, there we go. Everything's kind of in place. Now, the final step is we need to connect everything to the circuit board. Now I'm going to test fit this for a sec. So seeing how it all fits, I'm actually going to rotate my audio jack so that the tip thing is facing downwards. All right, cool. All right. So we're reaching the home stretch here. Now we gotta fit all of this junk in there. So where's my sheet? So this is where everything connects to. So our MIDI jack connects to these 2 points. Our audio, one goes to this ground rail, one goes to this point here. Our pots, positive and negative, go to there. Each wire will go to one of our things, and our DC input jack, ground goes to the negative rail, positive goes to V in on the board. Okay, so our wires are longer than they need to be on purpose. So that way we can make sure everything fits. All right, so let's do our power and our ground first of all. Now, a cool thing with these Adafruit boards is you can actually solder from the top as well. So what I'm going to do is I'm going to cut these a little short. Strip a little bit off the end. All right, and that's going to go to our negative rail. Let's do it right there. I'm going to use my hand to help grab this. All right, here we go. This part will actually go pretty quick. I'm hoping. Never say that because okay, there we go. Cut the end off. And our positive lead, where is it? It's going to go to V in. Right. And you can save these extra long offcuts for later. And let's just get it to V in. All right, this is kind of a little challenging soldering angle. Okay, that's good. What do I got? There's my cutters. All right, now, before I do anything, I'm going to do a quick power up test. Make sure this works. Here's a moment of truth. Adapter's in. Make sure nothing's shorting anywhere. If I plug this in, there we go. We've got some power. Nice. What should I do next? Audio? Let's do audio next. Okay, so let's cut that. So you gotta kind of, try to plan, if you put something, if you cut something, like, will you have enough space to put other things? Like, you don't want to cut it so tight that you can't get under the board if you need to until it's all in place. Where'd my cutters go? There they are. All right, let's do right in the corner here. Okay, there's our audio ground. And our audio positive will go right here. They were really flying now. So Wayne says, PLA print 50% done. Still no warping, looks good. All right. Thank you, Wayne. All right, there's our audio. That's going to be a tight solder, but we can do it. All right, our audio is in place. What's next? Maybe we should do our Midi. Or should we do our pots? I'll do the Midi first, and then the pots we'll do last. Okay, so what's the best way? Who's that? Roger. Thank you for subscribing, Roger. Thank you. Okay, so let me double check this. So our red wire is pin 5, which will go here. Six. And let me double check. So you don't want to do your MIDI jack backwards. That would suck. Yep. Looks good. And there we go. The other side of our MIDI jack. Let's strip that. So it may not look like it, but we're getting near the finish line here. Where does that go? Goes to the other side of the MIDI jack, goes to this side of the resistor. Once again, double check, triple check the diagrams. You know, do it once and save yourself some problems. Oops. And make sure all the strands make it through the hole. If it's a little hard to fit through, just give it a haircut and twist it. Who's that? Mauricio, welcome. All right, let's get that in place. And one thing, so now we're this far. I'm going to do a quick power on MIDI test. So what I can do, let's see. Is, let me go to this view. I'm going to hook up Ableton. So we're going to power and we're going to hook up MIDI. And we'll see if we're getting MIDI lights. Oops, get rid of this. So I got MIDI cable plugged in, and we're going to power it. And let's start this. right. Stop this. All right, so you can kind of see our light there. Let me get a better, and I don't know if you can see that, but as we're playing through this Midi thing, we're getting flashes on our RX light, which means we're getting signal in. Cool. Awesome. All right. So things look promising. Now all we have to do, last step, hook up the pots. And we is done. And get on the right camera. Hello. Okay. So the pots, we have our two lines, we have our ground. Now I want to do a little test fit and see how this is all going to sit. Let's see, did I cut, don't tell me I cut my audio ground too short. I did. Yeah, so let's do this. I made my audio ground a little too short after I just went on for hours about making sure you have enough cable. So what I'm going to do is I'm going to unsolder this. And luckily all the grounds on this board are connected together, so I'm going to connect it to the ground on this side. And that way, everything should be all right. It's one of those do as I say, not as I do things. A little soldered blob on the end. All right, good. All right, disaster, she is over. Okay, so maybe I should bring all these up. All right, so I'm just kind of doing a test fit, see how all this will work. And should I bring them, no, I'm going to do them all from the back. I think it's going to work. Okay, so let's do this nice and simple. So our power and our ground leads, remember our orange lead here is ground because I didn't have any green. So let's leave a nice generous piece, shall we? And that's going to go over to here. And let's do it over there. Let's see, Martin, how you doing? He says, really nice. What's the difference between this one and with the Arduino Nano and the first one with the Arduino Uno microcontroller? No difference. So they work functionally the same, except, you know, the first one we basically built an Arduino from scratch, and, you know, once this Nano came out, it's kind of like it did all that for us. So, you know, why not use it? Makes things a lot simpler. All right, so I gotta get this on the ground. So yeah, like, you know, I would say do the Nano version because it just makes your life easier. All right, pot ground, done. Okay, pot positive. Little stray piece of wire in there. Pot positive goes to positive rail, right? You really want to be careful with anything you put to the rails that there's no little shorts or anything. All right. If you want to double check, use your multimeter on continuity. You should not hear a beep between those two, but other parts of the rail you should hear a beep. Okay, looks good. All right, we're 5 wires away from glory. Now, we have to wire our potentiometer middle pins. So this guy will be, and this is looking from the top, all right? So this pin here will go to A0, this pin here will go to A2, the middle will go to A4, and so on. And you want to get those right, or else the controls won't behave like you think they should. So where are we? So this is A0. Where's his wire? His wire is there. All right. I'm going to cut a little bit off. And this guy will go to A0 on our Arduino. It's getting more and more challenging to move this stuff around. Where are we? Fish that under there. So you're always, at this stage, you're kind of thinking, how am I going to fit all this when it's all together? A0. Cool. And at this point, it's so packed that I almost don't need to hold it with anything. Okay. All right, where's A1? Let's do them in order. So A1, top corner. Here's its wire. Once again, it's real easy to get, kind of things backwards in your head. So you want to, especially at this point, really kind of think, give everything a second thought. All right, there we are with A1. Let's solder that. All right, where's A2? A2 is top corner. Let's find its wire. We're like 2 wires away from putting this together. Cut it off. A 3 bottom guy, and your wire is this. And we'll feed it through this. This is like packed full of stuff. What's that, Martin? I built your first Arduino with your tutorials. I love the Auduino synthesizer. It's really fun to play with that thing. Yeah, it is, man. It truly is. That's why I decided to build the Nano version, because I think everyone should try this. And if you haven't already, Martin, you know, go to the Notes and Volts Facebook page, and if you send me a picture of your build, I'll put it up there for you if you want. You know, you can show off a bit. And one more middle. And let's kind of wire this through. All right, the last pot, and we'll see what we did wrong. All right. Okay, now let's cut this. And, oh, one thing I should do is cut the pins off the bottom of the microcontroller, just so they don't short out on the bottom. I should have done that earlier, but never mind. I can still do it. Kind of giving it like a little haircut. All right, there we go. Wow, that's a lot of shrapnel. You know, double check, make sure there's no things floating around in there. But if I'm not mistaken, I think that's it. Now let's try to squeeze all this down. So ideally this should fit flush down on these. There's two standoffs printed in the case. We kind of want everything flush with that. All right, cool. We can, before we button it up, we can test it and see if it all works. All right, wish me luck. Power is good. Holy jumping. Holy, wow. So once you get it oscillating, you can actually play the oscillator without any MIDI signals coming in. All right. Awesome. Nice. So, all we have to do is try to cram everything in there and get it all nice and, you know. Now there's two standoffs that the board should screw into, and it's designed specifically for this Perma Proto from Adafruit. So, you know, it should all line up. Hopefully. Just kind of get everything smushed out of the way. All right, so there we go. So what you have to do, the standoffs are they're kind of, we're just going to thread the screw. I'm using M3 metric screws, and you can use we'll use some M3/8, so kind of designed everything so they use these. Helper, thanks for subscribing. I need help. All right, so what you got to do is kind of line it up. And then we'll just drop the screw right into it. I need a magnetic screwdriver. I want to do it the other way. So I'll put the screw in first, and then I'll line it up. And then, you know, like it's going to be tight at first because you're cutting the thread with the screw. Just kind of torque it down. So it's not designed, you know, usually in 3D printing you'd put a nut in there or something, but you know, I just want it simple. And so if you're, I'm not going to take it apart anytime soon, so there we go. Okay, screwed in. And I want to test it again, because sometimes when you screw stuff together, you tweak a wire or something, and that sucks. Right, that works. The other side. So we kind of got two oscillators. This top control kind of controls the intensity of the oscillator. The bottom one controls the pitch, but not really the note pitch, but more the frequency that the grain repeats. And we got another one. When you put the two together, and this middle knob is our scale knob, which I'll demonstrate in a bit. But the cool thing is it's all working, which is great. So, final piece. Okay, so first thing, this little dip switch sets the MIDI channel that this is on. So what you have to do is set the switch. In the programming code, there's a list of the 16 positions that you put this in to get the 16 channels. I'm on channel 1, and it's kind of like set it, and then you're gonna leave it on that channel for a while. Now to get the bottom on, if you notice on there's a little slot in these legs, and that's designed for an M3 nut to fit into, so that way when I screw the screw in, it's actually going to thread into a nut and not into plastic, which is not as strong. Okay, so here's one issue. bought like a box of M3 screws and nuts and stuff, and I noticed within that box there was two sizes of nuts. Now if I measure this guy, it's like 2.3 millimeters thick, right? But in that same box it had ones like this, which are 2.8 millimeters thick, right? And when I designed the box, I designed it with the 2.3 millimeter thick one. So yeah, if you want to find those ones if you can. So what you do is you just kind of put the nut into the slot, and it may be a little stiff, but and what I'll do is I'll use some, now watch how many times I'm going to drop this nut into this box. Where's my pliers? So you just got to kind of get it started in there and then squeeze it in, and once it's in it should kind of stay. And this is one of those things maybe I should have done first, and make sure there's no stray plastic in there. There we go. I use this wrench to kind of force it in a bit. Ugh. All right, bear with me. Ooh, don't drop it. That sucks. All right, I think that's going to be the way to do it. So just kind of. So it's supposed to be tight because you don't want it coming out on you. But there's tight, and then there's really tight. And this is really tight. All right, there we go. All right, once it goes in, it's not that bad. Okay, good. Try to get another one in. Yeah, see if I got better pliers. Apparently I don't. Oh well. Anything in here? Nope. All right, I'm gonna fiddle with that later. So we're just gonna put the back on with a pair of screws just so you can see it. I'm gonna thread a bolt through here, just once again using M3 8mm long screws. Okay, now we'll put the back. There's little indents for the screws. And with the nuts in there, you see you get a nice secure kind of surface to thread into. Let's get the other corner. There we go. Okay. And let's finish it off. Let's put some stick-on rubber feet on the bottom. Right, just kind of put them in the corners. I'll kind of help it keep it sliding around. Ah, there you go. It's nice and stable. Now, the final fun piece is we get to put the knobs on. Now, I didn't really do precise markings. They're more decorative. So what you want to do is put the knobs on and turn them, turn the potentiometer all the way counterclockwise. Put the knob at around 6 or 7 o'clock on the dial and tighten it up. Do the same with this one. Middle. And finally the last knob. right, there we go. All right, sexy. All right, now let's plug it in, give it a final test, make sure it didn't break anything. While I was doing all that. So Midi, audio, and power. Please work, please. There we go. Where's did I lose it? Some a little musical, a little more musical. So let me go here, and let's start. So what I'm doing on this So what this basically does, this middle knob, is whatever note is being played, it will play a major pentatonic scale in the key of that note. So you just turn it and you can get some really cool things. So in my Ableton, all I'm doing is I'm playing like one note for each chord. The root note of the chord. Right? And then as I sweep the knob, post it on SoundCloud. tweaking the filter a bit with this knob, and then playing the scale with the middle knob. Get the idea. All right. Now, so one thing I noticed in this is that the pots are actually acting reverse of what they should, and it's something I probably wired something wrong. But what you have to do, or what I could do to fix that, is, you know, the pots all have a positive and a negative wire coming off. Just reverse those two, and it would work perfectly. So I'll do that, you know, in another time, but other than that, it's perfect. Wonderful. There you go. Auduino Synth 3D printed case. Adafruit circuit board. Arduino Nano. And hope you enjoyed this. Like, man, that was a big, long stream. We're going like 3 hours now. So hopefully you enjoyed that. Any last questions? Hopefully Wayne can let us know if his PLA print worked out okay. And Martin, if you could, yeah, Martin, nice, glad to see you built one already. Okay guys, that was super cool, super fun, a lot of work, but I think it was all worth it in the end. As always, if you guys aren't already, subscribe to my Notes Volts YouTube channel. Facebook, I got a great community. You can send me stuff, I'll post it on the page, like projects you built. Twitter, you know, I tweet when I'm going live and when crazy stuff happens. Patreon, if you really want to help support the channel, that's a great way to do it. Notesandvolts.com, that's where you can find all the files and program code and documents I was using. And if no one has any objections, I think we'll call it a night. And I will see you guys next time. It was fun. And all right, guys, have a good week, and I'll see you later.